Fine. So we'll be working on the human resource database for understanding the concepts like constraints, aggregations, stored procedures, variables. For that, let me first initialize the human resource database. So I'll take a new query and I'll write a simple statement over here, use human resource. So it's already been in use, I guess it's showing over here. But if it doesn't show over here, you can just use the human resource and you can execute it. And now let's start on the first constant is a primary key. Now what is a primary key? Now you have been familiar with this particular term in my previous discussions also. The primary key is a column in a table which cannot have a null value, which cannot have a duplicate value. All the values in that particular column should be unique in nature. Now the question is, can a table have more than one primary key column? Yes, it depends upon the use cases. If you're working on specific use cases where we need to have two primary key column, yes, you can have. But a primary key column should always contain a unique value and it cannot accept null values. So a primary key is a kind of a column in any table. Now, for example, I have given in my previous discussions, I have talked about that there should be at least one column which should contains a unique value, and that can be considered as a primary key column or a primary key for that particular table. Now the question is how we can create a primary key column in SQL Server Management Studio. Now there are two approaches that we follow. First is we can create it through the data definition language where we can use the select or you can use the update function. And another way is to use the design of a table to mark a particular column as a primary key. Now let us understand the approach where we can use the design of a table to mark it as a primary key in SQL Server. For this, I'll come to this human resource database and I'll click on this particular table folder. Over here, we are working on these tables over here, states the details of the employees, the departments and etc. So if I open this employee table and if I right click on this particular table, I can select the design option. Now you can see over here the SID employee is marked as a primary key. Now what if I do a right click over here and you can see there's a lot of options over here. Among this we can see the option called remove primary key. So if you remove this column is no longer a primary. Now what if I want to make another column as a primary key over here? Now, for example, this employee number. Now let's first understand what is the difference between the SID employee and employee number column over here before we allocate one of the columns as a primary key. The SID employee column is a column which consists the ID of the employee which has been allocated by the system, a system generated icon, ID. But an employee number is the employee ID which can be also be a system generated, but it has certain criteria in terms of employee number. But an SID employee will be any random ID which is created by the system for any referential, you can say, value for any future references or any other internal log reference for which this SID employee column has been created by the system. Now what if instead of using this SID employee column, I want to use this employee number. The employee number means if I go to a new query, let's first see what are the values we have in the employee number and the SID number. I'll just simply write select start from employees and I'll execute it. So we can see there's a difference. There's some serial number that has been an indexed column has been allocated in terms of SID employee and a number which starts from 1001, 1002 has been allocated to the employee number. Now what I want to consider this particular column as a primary key for the table employee. Now how I can allocate this particular column as a primary key? We can use the right click option from our mouse and you can select this particular column or field header. I can do a right click over here and I can select this option over here as set primary key. Now you can see the moment I select it, there is a key icon that has been created over here. And now if I save this, the save option over here, And now if I come to this employee table and I right click on this particular table and I refresh it and I open this column, you can see this employee number column. There is a key icon which is prefixed in the column name, which signifies that this particular column, this employee number column, is a primary key which data type is int in nature, which cannot accept any null values, and all the values in this particular column are unique in nature. Very important terms in terms of working with primary. Now this is one approach of a primary key. Another approach which I generally don't use because these approaches are mainly used for the database admins is a DDL approach, that is data definition language. That is by writing a query where we can allocate a column in a table as a primary key. How to do that? So this is one option I have shown you where you can use the point and click options which is available in the SQL Server Management Studio, where you can right click and you can set a column as a primary key. The another way is to write a query for example, we can write a query as create table name. We can write a query over here, create a table. You can write a table name over here. For example, I'm just showing you a sample how this approach works. I can write a table coffee, and I can name the column name over here as coffee ID over here, and I can set this, or you can name this particular column as CID. You can set the data type as integer, and I can write as not null and a primary key. And I can close this. So you can write this kind of queries also when we create a table where we can define the table name and we can just define the column name where we have to define that this column should not be null and this can be a primary key. So there are two approaches, one is through queries and another one is by using an existing point and click option where you can define a primary key. Now the question is, when we know it is a primary key, then another constant that comes into the picture, that is a foreign key. So what is a foreign key? Now for example, if you remember in my previous sessions I have discussed that a primary key of table A can be a foreign key of table B. Now again the same things comes, that a foreign is there any possibility that a table can have multiple foreign keys? Again, yes, it can depend on the use cases or the business case scenarios where you are handling. A table can have multiple foreign keys. Now, in order to understand the concept of foreign key and how we can create a foreign key in SQL Server Management Studio, let us understand with an example of two tables. Now what I will do, I'll take two tables over here. The first table is an employee table and the second table is an employee location table that we have in this particular database. Now what I want, remove this particular primary key over here and let me assign an SID employee as a primary key and I'll let me save it. Now a foreign key is basically used for a referential identity, means we can refer a table to a foreign key. We can connect our table to a foreign key where we can use that particular foreign key as a reference connect to that particular table. But the question is how to create a foreign key in a SQL Server Management Studio. So what I have done, I have taken two tables, the employee table and the employee location table over here, where in the employee table I have actually made the SID employee as a primary key. If I refresh this particular table over here, you can see now SID employee is the primary key over here. Now what I want, in the employee location table, you can see the SID employee column is available over here. I want to use this particular column. I want to refer this particular column as a foreign key. Now how to do that? Now in this employee location table, if you come down, there is a folder over here called keys. If I right click on this particular folder, this keys folder, you can see there's an option coming up over here as columns. If you right click over here, you can see there's an option coming up, a new foreign key. Now if I open this particular key folder, there is no such keys available as of now. So what we will do is create a foreign key with the help of this particular folder. I'll do a right click over here, click on new foreign key, and there will be an option coming up where you have to exactly set a procedure to to use the SID employee as a foreign key in the employee location table, which is a primary key in the employee table. And you can see over here. Now, you can see over here the options like general, identity and table designer. Under general option, you can see there are option called table and column specification. This is the option through which we'll create the foreign key. Now, if I select this particular option over here, you can see there's three dots over here. Now, if I click on these three dots, over here, we'll have two sections. The first is a primary key table and the second is a foreign key table. Now, if you think logically, guys, the primary key table over here will be the employee table because that is the table where the SID employee is a primary key, right? So what I will do, I'll select the employee table from here. And if I come down to the action area, I have to select the column name. Now we can see the primary key table, I have defined it as an employee table and the column name is SID employee. Now let me come to the foreign key table. The foreign key table over here should be employee location. And the column in this employee location table which I want to convert or use as a foreign key is SID employee. So I have defined a specification in terms of creating a foreign key within the employee location table with the help of the primary key table, that is an employee table. And now if I click OK, I click add and I click close, employees, I guess I used some steps. SID employee. And now if I refresh this key folder and if I open this, if I save this, you can see this SID employee has a key icon which is quite different from the primary key which is available in the employee table. And these two foreign keys actually I've created twice the foreign key. I can delete one. So you can see this foreign key, the number of foreign key this particular table has been listed over here. So this table has one foreign key which has been created and this is the icon of the foreign key. You can see the color of this icon is quite different than what we have in terms of the primary key. So you can identify that this SID employee in the employee table, in the employee location table is a primary key, is a foreign key which is a primary key in the employee table. So let me create one, so let me see delete this foreign key. Let me create one for the so I deleted it and if I refresh this table now, you can see the foreign key has been removed. So let me create the foreign key once more. I'll do a right click on the key folder, click on new foreign key. I can come over here, select it, this option, and I have to define the primary and the foreign key table. The primary table will be the employee table and the column will be employee ID or SID ID, SID employee. And for the employee location table, I'll use the SID employee column and I click OK and I click close. Now if I refresh the employee table, now I have to save it first. If I refresh the employee table over here, I can see the SID employee column has been marked as a foreign key and this particular foreign key is also available under keys column. So these are repeated values which are created because I'm using the same option again and again. So you can choose to have a one option and you can remove one and you can change the name of this particular instance of the foreign key that is available under key folder. Now you can see the difference between a primary key from the employee table and a foreign key from the employee location table. So this is some of the constants that we can create. This is some of the rules or limitations you can see we can create in terms of the foreign key and the primary key. The next constant that we can discuss is about a default constant. A default, as the name implies, that we can set any column as a default in any table. Now, how to set a default? For example, if you have a table over here, for example, let me take the manager table. If I right click on this particular manager table and I click on design, so I can see this particular manager table has four columns: the SID employees, the position, the from date, and the, you can say, the to date. Now what I want, I want that any particular column, I want any one of the column in this particular manager table to contain a default value. Now that particular value can be any value. It can be a default value, can be a blank also. So if I specify that particular column, okay, it should not contain any value. The value should not be specific. Then we can use that particular column as a default value as a not specific. Now how to do that? How to set a column value to default? For example, now suppose if I come to this position column. In this position column, if I come down to this column properties over here, if I expand this particular property over here, you can see there is an option over here called for this column is default value or binding. Now if I specify this option as not specified, you can see the moment I press enter, this particular not specified column is delimited, means it has been covered under the single quotes. So what I have done, the default value for this particular column called position, I have made it at not specified. So whenever we will try to insert a value in this particular table, this particular column will be showing us as not specified. Now what if I want any particular value which I insert in this particular column in terms of date, that date should show me the present system date. Now how to do that? Now for example, if I select this from date column, for every column I have a column property where I can see this default value and binding option. This is the option through which we make a column value default. So we have just made the position column default value as not specified, and then I have selected the next column as from date column where I'll use the get date option to get the present system date over here. Now if I save this, now if I refresh this particular table and if I select a new query, and now for example, if I write a small query over here, now what kind of query I can write? Let me select first all the data from the manager table. Select star from manager. If I execute it, I'll get all the values. Now for some reason, what I want this particular SID employee 100617 to be updated in terms of the to date. Now what will happen? Let me insert a new value. I'll write insert into managers. Let me define the column name as SID employee. Let me define the column name as to date, and the value which I want to update over here is, let me see what values can I insert. For the SID employee, I can define the SID employee first, 100617, and for to date, let me insert a value like, what date I should insert. Let's insert 2001. Let me close this, and now if I execute this particular value, I can see one row has been affected. And now if I select star from managers and let me sort it by 1, and if I execute it, you can see this second column where we have set a default value in terms of the position as not specified, and where I have set a default value for from date to get the present system date from my system. You can see the present system date over here, that is 2021 0206, which is today's date, and the to date value is 2001 which you have tried to insert over here to the insert statement. So what does the default constant does? Whatever column you set as default and whatever value you can set, whatever function you set for inbuilt function, like for example I have used for the date column, it will capture the present system date and it will mark the position column as not specified. Now this is a kind of a constraint after primary key, foreign key, default, which we can apply to the table as a constant for any table data. So this is one of the constant. The next constant is also a very simple constant, that is not null. Now not null you can see over here. If I come to any system table design over here, you can see this is also a type of constant where we can make a column null accepting a null value or not accepting a null value. So not null is also a type of constant which you can make it at the design level in the SQL Server Management Studio, which also sets a limit for any particular column whether it should accept a null value or whether it should not accept a null value. Now you know the use cases in terms of primary key or the foreign key where you can set a column and you can make that particular not to accept a null value in terms of primary key. Fine. So the next topic that I'm going to talk about is again a very interesting topic, and that is aggregations. Now what are aggregations? I have discussed aggregations in Tableau and in Power BI also, where we use multiple values to get a single value. Now we can use the function. We have used functions like count and count distinct kind of functions and aggregation average functions. The same way we'll use those aggregate functions in a SQL Server. So that is called SQL aggregations. The different types of functions that we have, aggregate functions that we going to work today is count, count distinct, sum, average, mean, max, having clause. Having is also kind of an aggregation. It's a very interesting aggregate function that we have in SQL, and you can say having is a very interesting clause in terms of aggregations that we have in SQL. So let's start with the first aggregate function, that is called count. So again, I'll go for a hands-on example for all these examples. I'll take a new query. So we'll take the first aggregate functions as count. Now let us work on a use case for this. Now what I have a requirement where I'll be using the employee location table to count the employees in terms of the various cities with respect to a particular country. I repeat, I want to count the employees with respect to cities for the various cities with respect to a particular country. Now how to write this kind of aggregate functions? Now count is a very simple function. We can, what count does, but how we can implement a count in SQL, that is the area of focus. Over here we have a table called employee location. You can see this employee location table over here. Select star from employee location, Control E. So you can see this employee location has columns like employee number, city, state, region, region name, country, region name, and postal code. Now the requirement is that I want to count the number of employees in terms of SID employee for each of the cities with respect to any particular country over here. So how to write this kind of queries using a count function? So you can write select city, comma, SID employee. Okay, just let me first define the table, that it will be easy for me. Select from employee location. So I've used the employee location table. From this employee location table, I will use the city column, comma, I'll use the SID employee. Now what I want, I want to count the employee on the basis of this particular column. Before that, before I implement the aggregate function, so I have selected the city and the SID employee from the employee location table, and I want to count the employees with respect to the country. Let's name it as Australia, where the country region name is equal to Australia. And now what I want, I have selected the required columns, but I want to count the SID employees, the employee ID, the employees for each of the city from this particular country. So I'll use a count function for this particular column, and I want to show this particular column as employee count. And I want to group the city column from this particular table. Now let's see what happens if I execute this query. So you can see the approach that I have followed. First, I have defined the columns as per the requirement. I have defined the table name, and also I have defined the condition. The condition should be the country should be Australia. So now if I execute it, you can see the query is getting executed. Now I have got all the employee count for each of the cities for the country Australia. You can see Brisbane, you can see some of the familiar cities of Australia like Sydney, Hobart, Rhodes. So you can see the employee count for each of the city in terms of the country Australia. Now if I remove this group by clause from here, now if I execute this particular query without the group by, it will throw an error because we cannot use a column name with an aggregate functions without a group by clause. So you can see the city name, column name is used with an aggregate function. So whenever you are using an aggregate function and if you are using a column with that, so you need to use a group by clause to group that particular column. And now if I select this particular query and I execute it, you can see that I have got the options over here. So this is how we can use a count function, a count aggregate function with a specific condition and a multiple columns. Now what if I want to count the employee number from a specific column? Now let's take a new query for this. Now this is a very interesting example. You will see a very good difference. Now I want to show you the difference between count and count distinct in SQL. Till now we have count function which have also taken the null values into consideration, duplicate values, everything. It has been counted. Now what if I want to know the specific values in a column? For that, let me take a new table for this. Now what I will do, I will use let me select the salary history table. What I will do, select from salary history. Now let me see what the salary table first contains. So I'll write a star over here and I'll execute it. So this salary table contains the SID employee, employee number, current salary, the salary from date and to date. Now what I want to count all the distinct employee from this particular column. First, if I use simple count function, if I simply use the count aggregate function, count employee number, you can see EMP count. Let me take it again. And now if I execute it, you can see over here that I have got a number as 9 lakh employees over here. So 9,01,617 employees are there in this particular column. What if I apply a distinct function with this? Just keep an eye on this number. So this particular count function has taken all the rows into consideration, but the moment I apply a distinct with employee number, You can keep an eye over here. It's 9,01,617 numbers, right? So if I execute now this particular query with a distinct function, this number has reduced to 2,58,986. That means this particular column was containing multiple occurrence or duplicate values of employee number. That can be an obvious reason because this is a salary history table. It will capture all the histories of the employee in terms of the salary hike or the number of salaries that have been paid to the employee. So you can find the difference between a count which has been applied with multiple columns to specific conditions and how this count and distinct count actually affects the result of a table. Similar function we can use a sum function. Now with this particular sum function you will try to understand a new example as arithmetic overflow. The problem of arithmetic overflow in SQL, a very common problem that we have in a that we face in a day-to-day work with SQL Server. Now, what is an arithmetic overflow? For that, just let me show you something. Just allow me to take the control for a second and let me open something and show you what is an arithmetic overflow. Now, if you remember, in the first initial classes of SQL, I was discussing the concept of data type, right? Now, where I have defined the range for each of the data type. So, each data type that is big int has a particular capacity of values that it can hold. For example, int has a specific range of data that it can hold. In case of small int, tiny int, decimal, it has a specific range of data that particular data type supports. Now, what if this particular range exceeds for any of the data type? Then the SQL Server will throw an error as arithmetic overflow, means that the value of data, the value this particular data type is containing is more than what it has been made for. And if you understand logically from the word itself means arithmetic overflow means the range of value for this particular specific data type is more than what it is meant for. So let's understand this particular error with an example. So I'll go back to my SQL Server and in the studio, I'll take a new query. And through this example, I'll show you another aggregate function that is called sum. For this particular example, I'll use a table called, let me take a table called current personnel. There's a table over here called current personnel. What I will do, I'll write a simple query where select star from current personnel. And if I execute this query, you can see the tables like SID, employee, employee number. These are the columns that we have. Now what I want to apply a sum aggregate on the current salary column from this particular table. So I'll write a simple query as select from current personnel table where I want to apply a sum function on the current salary column. And now this current salary column may contain some decimal value also. So what I can do, I can use the decimal option over here. And let me define the range of this particular decimal. Decimal, yes, current personnel, okay, salary, yeah. Let me understand this error first. Sum is not a recognized built-in function. That means it's an int function. Sum will always return in int, and if I use the decimal over here, okay. Let me convert the decimal into int. And now, if I close this, I execute it. Okay. So you can see this conversion of decimal into, because sum is an inbuilt function which returns an int kind of data. Now if I use a cast, it has what it has done. This current salary column which contains can contain a salary into decimal point, it has allowed this particular conversion of decimal into int. Now, if I can execute it, you can see that I have got a value of this particular sum from the current salary table. Now, whenever you are using this kind of options, you might have a chance to get an arithmetic overflow error over here. Now, as I explained you, this is a common error that we face in this particular stage while working with these aggregation functions. So we can understand this arithmetic overflow functions at this particular. This is a very common stage where you use a sum function to calculate this kind of aggregate values, and then there is a possibility that the system can throw you an arithmetic overflow error. So in that case, you have to be very careful in terms of defining the data types. Now this cast function is what it does is converting this decimal into an int data type, because sum may return a int value which is int in nature. So this cast function plays a very crucial role over here while working with the sum value. Similarly, like sum, we have an average. We can use the same column as an average to calculate the average for the salary over here. So you can take a new query and I can just paste this particular column. I can just simply change it, the sum, into an average. And what I can do, I can name a column name as average pay. So now if I execute this, you can see that this is an average pay that I have got from this current salary column. Similarly, we have one more very interesting, you can say, aggregate function is called mean and max. So mean max, as the name implies, is used for handling the minimum and the maximum value. For example, if I want to select the minimum salary and the maximum salary from the salary history table in terms of the employee number, how we can do that? For example, I can write a simple query: select from employee history table or salary history table So I've selected the salary history table, and now if I select the column like EMP number from there, and I want to know the minimum salary from the salary history table. So I'll write mean, I'll define the column name, and let me name that particular column as minimum salary. I'll take another function called max on the column name current salary, and I'll name that as a maximum salary. Now, if I want to use a sorting group by clause over here, which I want to apply in terms of the employee number, and now if I execute it, I have got the employee number column and the minimum salary for that particular employee number and the maximum salary for that particular employee. So I have got both the information from the salary history table by using the current salary column, where I have got for each employee I have got the minimum and the maximum salary. Now what if I want to find a movement in terms of the salary? Means how much is the difference between the minimum and the maximum salary? Now every employee goes through a cycle where his salary is increased or that particular salary is appraised. That can be a very shocking thing for an employee if the salary decreases. I'm sure that this kind of thing doesn't happen anywhere. But yes, the movement in terms of the salary is very important part of an analysis whether we do. So how we can calculate the movement for each of the employee, how much increase has been done. And what I can do, I'll write one more query, and I will write minimum current salary minus max current salary, and let me name that particular column as now if I execute this particular query, I've got another column salary movement. But over here, you can see that each of the movement value over here is showing a negative value. So you can remove this particular negative value by using one more built-in function that is called absolute function. So for applying absolute function, you have to type ABS, and I can put this particular two values within this absolute function. And now if I execute it, you can see all the negative values has been removed, and you can see the actual salary movement. So for each of the employee, the actual height in terms of the salary movement has been captured in the fourth column, and we have removed the negative by using the absolute function over here. So this is how we can use the min-max aggregations in SQL. The next is a concept called having. Having is not a function. It's a clause that we use in SQL. Now, why we use having clause in SQL? Now, what happens? We use a where clause when we define an aggregation, where we define a condition. So you all aware of the where clause that we use in a SQL query, right? Which actually takes care of any conditions like where the country is equals to Australia, where the employee ID is equals to such an ID. Now, what happens? Where clause has a limitation. What limitation? The limitation is that we cannot use an aggregate conditions over there. For example, let me show you a new query over here. So I'll take a new query. Now, what if I want to select the employee number? So I want to select from the salary history table. From this table, I want to select the employee number, and I want to use a where clause where the current salary is greater than 6 lakhs. I close it, and if I execute this particular, so you can see there is no error over here, right? What I have done, I define a condition, which I always do for the where clause. But this condition has an aggregate function. Now, if I execute this particular query under where function, the system will throw an error. And what is an error? An aggregate may not appear in the where clause unless it is a subquery in a having clause. So we have to use a having clause to handle this kind of conditions where we are using aggregate functions within that condition. And now, if I replace this where with having, a having clause should always be aggregated with a condition where we can use a aggregate function. And whenever we are using an aggregate function within a having clause, we have to use one more clause along with having that is called group by. And what I want to group by over here, the employee number. And now if I execute this particular query, you can see that I have got all the employees whose salary is more than 60,000. Okay, let me increase the value to 6 lakh. You can see these are the employees whose salary is greater than 6 lakhs. Over here also I am using a condition which can be easily used in the where clause, but the only limitation that this particular condition have is that we have an aggregate function with it. So this is how we can use the having clause. Now always you should remember, it's a very important interview question in terms of where and having. Where to use a where and where to use having. Both are handling conditions, but where cannot handle a condition where there is an aggregate function. For that we use having, but having clause should always be used with a group by clause. Few things, takeaways, that you should always use a group by whenever you are using an aggregate function within the columns also, as I showed in a previous example. Second, you should always know that you cannot use an aggregate functions with a where clause, so we have our option called having for that. The next topic, we'll talk about SQL programmability. So where you will be talking about variables and store procedure. Very interesting topic again. Now, what are variables? A variable is an object that holds a value of a specific type. You can say it can be user-defined variable, it can be a system-defined variable. Now I'll talk about both the types of variable and how we can use variable in SQL. So variable is a kind of object that holds a value. That value can be float, integer, date. So that's why the definition states that a variable is an object which holds a value of a specific type. Over here, type means data type. Now there are two types of variables that we deal in SQL. The first is user defined and the second is system defined. Now let us understand both the types of variables. So for this particular discussions, we'll be using this particular folder over here, that is SQL programmability. I'll take a new query over here and let me first write a user defined variable. So you know what is a variable? It holds a value, right? Now in SQL we have two kinds of variables, system defined and user defined. A user defined, as the name implies, the user can create a variable and that user can use that particular variable to store a value. Now how to define a user defined variable? We use the word declare for that. Declare. Let me define a variable name as, so I will use the @ symbol to define a variable. So let me define a variable is my name. So I've defined a variable and the definition says it's an object that holds a value of a specific type. That means I have to define a type also. So this particular variable will hold a data type of varchar. And the limit of this particular varchar, so you know what is the difference between char and varchar. So it's a dynamic, you can say, data type. So let me define the limit as 80 over here. Now that I have defined the variable, I have also defined the type of the variable. It's time to insert a value to this particular variable. So let me define the name as Amit over here. Now one important thing that I want to highlight over here, whenever you declare a variable always works within a batch. Now what is a batch? Batch is this particular statement. So whenever you're executing a variable, it should be executed within a batch. So I have defined the first statement of the batch as the variable name, the type of the variable and the value of the variable. Now it's time to execute this batch. How to execute this batch? I'll come to the next line. I will simply write print variable name. And now if I execute it, you can see my name over here. But if I simply execute this particular part, you cannot see the result over here. So always you have to execute the variable within the batch. So this too is a part of a batch. So if I execute it now, you can see my name over here. Now the next variable is how we can use a number. So let me take one more example. To declare, again is the declare function @my phone number. As now this time I will define my phone number as int, and this time I will not assign a value to this variable through a equal to operator. What I will do, I will take one more way to insert the value as I will take a set option and I will define the variable name, and now I will assign a value as my phone number as, and I will close it. And now if I want to show this particular number, I use a select statement and I can also call that particular variable. And now if I execute this particular batch, you can see the number over here. So these are all user defined variables that I am talking about. Now what if I want to use the system defined variable? These are all variables which is created by me. Now what if we want to use a system defined? Now system defined are inbuilt variables that SQL have. You can see these are local variables. User defined variables are, you can say, local variables which life cycle is within that particular batch. You cannot use this particular variable with another instance of a database. No. So how we can use some of the inbuilt variables? For example, if I want to know the version of my SQL server, I can write select @. You have to give 2 times @ and you can see the system defined variables over here. Now if I want to know the version of my SQL server, I can write @ version, and also I can use the inbuilt variable to know my server name also. And now if I execute it, you can see the version of my SQL and the server name is star, which I am using. Now what if I want to use some system defined variable along with the tables that I have in my database? How we can use the system defined variable along with the database? For example, if I select star from, let me take an employee table, And now if I use select at the rate, I want to count the number of rows of this particular table. And now if I select this to batch and execute it, you can see that I have got two outputs. The first is the table, the employee table data, and the second the number of rows from this table. So there are total 3,24 rows. Let me check. You can see 3,24 rows. So you can use the system defined variables along with the tables that we have. So this is how we can use the two types of variables that we have. The first is the user defined, which I have used for showing the name, we have used for showing the phone number, and the second is the system defined. Now, why I discussed about these variables? Because variable plays a very important role in stored procedure. Now, what is a stored procedure? A stored procedure is a set of statement. Now, what is a statement? This is a statement. It's a set of statement that is grouped in logical unit and is stored inside your database. Try to understand the definition. It's a very simple English definition. A stored procedure is a group of statement. What is a statement? These are all statement. It's a group of statement which is organized in a logical unit and is stored within the database. Or you can say a procedure is a function that is written in SQL with the help of certain variables, with the help of certain data definition language, that is select statement or update statement. So a procedure contains a variable as an argument. It can contain a select statement. It can contain an update statement, insert, but it should be organized in a logical unit which can be stored within the database. That's why it is called stored procedure. Now the question is how we can write a stored procedure in SQL. First, what is the benefit of writing a stored procedure? Now stored procedure is a very what you can say, it improves the performance of your query. First, it can be referred, it can be used again and again for solving any, for working with any specific business or use cases. It makes your query more and more fast, and it's very easy to maintain a stored procedure in a SQL server. Now these are all the terms that I'm using which are used by a database administrator. So that is the purpose that the DBA always creates a stored procedure. So before we write a stored procedure today, it was very important for you to understand all the aggregate functions, because we use a lot of aggregations, we use a lot of constants, we use variables, system defined variables, we use a lot of user defined variables within a stored procedure. Now let us see how we can write a stored procedure in SQL. Now I'll take a very simple use case that it will be easy for you to understand. Now for example, we have to define a scenario. Now I'll be using employee location table. Now if you remember, I have used a count function where I was counting the number of employees from the employee location table. Now there are two ways, or not two ways, you can say there are two rules for working with stored procedure. First, you have to define the stored procedure. Second, you have to call the stored procedure. Means you have to execute the stored procedure. I repeat, there are two steps that we follow while working with stored procedure. First, we have to define the stored procedure, what that particular stored procedure should do, and then we have to execute that stored procedure. Now let us understand the end-to-end, how we can define and how we can execute a stored procedure in SQL Server. For that, I'll take a new query. And what I can do, let's first define the stored procedure. To define a stored procedure, what we will write? We write create procedure, and we'll name this particular procedure as, you can see, let me name it as EC, for example. And I'll pass an argument to I'll define a variable in this particular procedure. So I've defined the procedure name, create procedure EC, and a variable which will hold a value as a part of this particular procedure. Now why I'm defining this variable, it will be clear for you. So I'm defining a variable, for example, at country, as I said, it will always start with at symbol. The data type of the variable, let me keep it as varchar, and let me define the limit as 50. So what I have done, I have declared the procedure, and also I have defined the parameter or the argument that particular procedure should take. And now it's time to define the body of the procedure. I'll come to the next line. I'll use the word as, and now I'll write data definition language to define the function of this particular store procedure. So what is the function over here? I'll write a very simple function. Select from the employee location table where I want the country region name So we have the country region name column in the employee location table, where I want the country region name is equal to what I can do. I can define it as the variable name. Let me take the variable name over here. So country region name should be the variable name that we have defined over here. And now what column I should select from here? I select the employer, the city, and I want to count the SID employee in terms of the city as employee count. And now let me group by the employee, group the city, group by, and also I want to sort the employee count in descending order. Let me add one more clause. So I want to sort the employee count column, EMP count column in descending order. My store procedure is complete. So what I have done, I first defined the store procedure, then I have defined a variable as a parameter or argument for that particular store procedure, and also I have defined the function that particular store procedure has to be performed. So this particular store procedure, what it will do, it will count the employees the way that we have done in the count function earlier. So we have used that particular function only within this particular store procedure. So as per the rule, we have defined the store procedure. Now it's time to execute it. How to execute a store procedure? We'll come to the next line. I'll use the word exact, the procedure name, that is EC. And now I'll use that particular variable country over here. So exact EC @ country, where I want to assign the country Australia per se over here. And now if I execute it, you can see the command has been successfully executed. And now where I can see this particular store procedure, if I refresh this programmability folder, you can see the name of this particular store procedure that I have created. It has been stored under this programmability folder under the system stored procedure, where I have created this EC procedure over here. Now what if, now suppose over here what I have done, I have used a variable which is I have already declared within this store procedure. Now what if I want to use another variable which is not a part of the store procedure? I want to select one more country with the help of a variable which is not a part of this particular store procedure. So till by now you know how to declare a variable, right? So let us declare a variable, another variable which is not a part of the store procedure. So I write declare. I write another variable as country. I'll define the data type as varchar. I'll close it. And now if I define a country called France, so what I have done, I have defined a new variable which is not a part of this particular procedure called EC. So I have defined a new variable. I have defined a data type of the variable, and this time I have selected the country France, which is in the country region name column. Now if I want to execute this particular variable as a part of this procedure, what I will do, I'll go to the next line, I'll use the execute function, I'll use the procedure name, I'll use the variable that I have defined with that particular procedure, that is country, equals to, I'll use the new variable name @count underscore in. And now if I execute it, you can see the results over here. So all the countries from France and all the countries in terms of the employee count has been highlighted over here. So this is how we can use a variable outside the procedure to execute that particular procedure over here. And this procedure will always save under the programmability folder under your SQL Server, under this particular database that we have. So you can see this procedure name, and this is how we can declare another a variable outside the scope of the particular procedure, and you can use that particular variable to execute that particular procedure. Now this is how we define a store procedure, and this is how we execute a store procedure. The body of the store procedure can be any data definition language using aggregate functions, where clause, or select statement. But to execute a store procedure, you have to always follow this particular step, where you have to use an execute function, the exact function over here, to execute that store procedure. So this is how we define the store procedure in SQL. This is how we work with variables in SQL.